Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over this Unit 5 section on the final exam study guide. So the first thing is going to be exponential growth versus exponential decay. And the main thing to know is with both of these, you're going to be using the equation of an exponential function, which is given as y equals a times b to the x. Now, the b stands for the base, so this right here is the base, and that's pretty much when you have an exponential growth, the base is greater than 1. When you have an exponential decay, the base is going to be less than 1. And so when you have an example of an equation, you could pretty much just make this base in the parenthesis, let's say greater than 1, that could be 2. For decay, you could have the base less than 1, maybe 0.5, or any fraction that is less than 1. And it doesn't matter what is in front of this. This could be, this could be 1/2 if you wanted to, but even though this is less than 1, it doesn't matter what that is. For growth, it's all about what's in the parentheses, so you really want to focus on just this part being greater than 1. And then the same thing for this too, for the decay. Even if this was like a number greater than 1, that number in front doesn't matter because this is less than 1, and that's what makes it a decay. Okay, so the next one would be what is the horizontal slope asymptote? And the asymptote is the boundary that this exponential equation is approaching. And so you can see right here, it's pretty much flat right here. And so this is where the asymptote would go. So you'd have this here, and this is going through the point -3. And because this asymptote is horizontal, it's going to be y equals -3. Now, for the equation, you kind of have to know what the base is, and really that's the same thing as knowing what the multiplier is. What are you multiplying the first point to get to the second? So in this case, if we look at these 2 points, this is let's see, 1, 2, 3, 4 over 1. So I mean that's important for when it comes to the equation of an exponential function, because we have to fill in this right here. But of course, because when you have this, the asymptote's always at 0, but notice that now the asymptote's at -3, so it's been shifted down 3. So if I move this up 3, let's say this is going 1, 2, 3 up, I'm going to move all the points up 3, and let's see what happens. So this is going to go from here 1, 2, 3, so that would be this point, and then this point 1, 2, 3, that'll be this point. And so if we were to graph this equation and shift it up 3, it would go like that, where the y-intercept, which is its starting point, is at 2. So that would go right here. This is the y-intercept. In that case, it's 2. In this case. And then from when you look at this point, it starts at 2 and it goes to 6. So what do you have to multiply 2 by to get to 6? Well, that'll be times 3, which is our multiplier is 3. So if we put all this together, we'd end up getting y equals 2 is the y-intercept, 3 is the base, and we could see that it's greater than 1 because it's going up, raised to the x power, and then -3 because this whole thing was shifted down 3. Now when you're talking about the domain is how far left and right the graph goes. And so in this case, you see that there's an arrow left and an arrow right. And so the domain would be negative infinity, positive infinity. The range would be how far the graph's going up or down. And so if we look at the original equation, it's going up forever, but it's going down and it's stopping at -3. So we're going to stop. We're going to make it go down to -3 but up forever. Notice I'm not putting a square bracket on this -3 because it's not making contact with this asymptote. And then end behavior is a left and a right side. So the left side is going to be x with an arrow to negative infinity. The right side is x with an arrow which is approaching, means approaching positive infinity. And so what's the left side approaching? Well, the left side is going down to -3. So that would be this. And what's the right side approaching? The right side is going up forever. So the f of x is going to be positive infinity. So the x represents left and right. The f of x represents down and up. Alright, so number 10. So what does it start with? Begins with 100 cells. That's what A represents. A represents the starting number, or the y-intercept if you want to call it that. B represents the growth or decay. Well, in this case, it's the bacteria is dying, so that means it's going to be 1 minus, and then 20% as a decimal is 0.20, and so that's what that would be, the base. So if you put these together, you'd end up getting, and again, this is all given to you right here. This is your initial value, and that's 100, and then this is your base, which is a growth or decay. In this case, it's a decay because it's dying by 20%. So if we put this together, this is 100, and then 1 minus 0.20 raised to the x. But if we want to simplify that, we could make it 1 minus 0.20 is 0.80 raised to the x. And this kind of goes along with exponential decay because it's less than 1. And so to figure out how much would be present in 5 years, that would be plugging this into the x, because x is the number of years. So if I were to rewrite this and replace the 5, I'd end up doing PEMDAS at 0.80 raised to the 5th power. Let's see what that is. So 0.80 raised to the 5th power is that, and then we could, the next thing we'd end up doing is multiplying it to 100, since this 100 is touching the parenthesis. And so I could pretty much just put that in decimals as well. And that's 32.768. So how much bacteria? Well, it'll be this much, 32 and a little bit more than that. Okay, so these are the last two. Now, when you're converting, you have to know what is the base. And so in this case, the base of this exponential equation is 3. And so when you convert it to a logarithm, the first thing you're going to write is log. And then the base of the log goes right here. Well, it's the same as the base of the exponential function. And so that's still going to stay 3. So I'm going to just label that as the base. And then when it comes to the equation, this 10, instead of being on the right side, is now going to be on the left side. And this x, instead of being on the left side, is going to be on the right side. And that's it. Same thing for this one. So this 4 is the base, and so if we're writing it as an exponential equation, we're going to want to make sure that the base stays the same. So if this base is 4 here, here's the base on the exponential, and then we're going to switch the order of the two other terms. The 8's going to go on the left, and because this is an exponential function, we're going to make that 8 an exponent, and then the x is going to go on the right. And that's the answer for that one. All right, well, I hope that helped.